So hello everyone. Um, I'm from Baltic-RCC. I don't know if everybody know. I see some Chorizo people and RT people. They for sure know. But basically, I'm here to talk both Baltic-RCC foray into open source and also our implementation or using an open source tool. Many know it, pyPowSybl. So. Anyways, we are located in Estonia, Tallinn. We actually have offices also in Latvia and Lithuania, so we are working in Baltics. What RCCs are doing, RCC's goal is to ensure grid security. So historically, TSOs have been more or less their own. The grid has been started, somewhere in the center or in cities, and then it's grown towards the borders. It has never been developed for cross-border capacity in origin. But Europe obviously has grown together. And for clean energy and other things, we need capacities on the cross-borders and more cooperation. So for that use case, TSOs and Commission in a way came together and moved to these regional coordination centers or security centers. And we are one of the 6 of them. There are others in Europe. Our focus is local, but also we look all over. And what are we doing, or one of the services that we are doing, for any assessment that you want to run, you need to simulate. So grid model is nothing more than a concentration of reality to some set of assumptions or parameters that you want to study. So you're not going to simulate the whole reality. You look at the reality that's relevant for your use case. So here we are all talking about electrical network. And what we are trying to do is to collect electrical networks from all the TSOs or transmission system operators and make one big one and make sure it works. And this is pretty much where this process stops, meaning every other service is running then on top of it. So it's on its own, it's not very critical. It doesn't provide clear business value, but it is the basis and fundament for everything, because all the services will be running on that. So it's very critical in a timely manner, in a good quality, get a good base model. So TSOs submit their models, we collect them, we check them, we merge them together into one, and we publish them. And this is distributed along RCCs. We do it in rotations. So what were our challenges? We started with many of them. So first of all, our assumption was, as we started quite a young company, or even before it was not a company, it was a cooperation platform between the TSOs. We expected that we can take an off-the-shelf tool and just use it, which was more or less okay. But what we ran into is that energy sector change is quite slow. So it's not like people are used to releases every week or every month even. It's like maybe once or twice a year it's a release. But at the same time, you can imagine we have 42 models to collect. The standard is new. The standard is not fully developed. There are things people have not thought about it. So what we run into is that the knowledge about the standard is really distributed. On Siemens or ABB or any other company, large or small, there's maybe 1 or 2 people knowing about the standard. So everybody's solving the same issue, but in very small groups on a huge code base, because everybody needs to maintain their own code base to solve the same issue. Then we also ran into issues that everybody, why was the different data format you decided on, was because they were proprietary ones. So NSOE, together TSOs decided, let's go on an open format, which is standardized, but it was never used at this scale. So some made a very simple modeling, few lines, few buses, few generators, nice. Some went full in to the 0.4 kV to full detail. So you would have models from one edge to another edge, and the off-the-shelf tools made some assumptions. And so made different assumptions. So what we ran into in the reality was that we wanted fast-paced development from our vendor, where they were only expected to make a release once a year. And also their knowledge of SIM was limited to few experts or one expert. And we wanted faster, better, sooner. And this was not doable in that setup. So we were starting to look how to do it on our own. And almost around this time, a little bit before, like in August last year, we made a proof of concept. We took pyPowSybl, made our own Python code around it, tested if we can collect the models, published the CGM, and we could do it for a small set of models. And we were like, okay, we'll start exploring this. We have a proof of concept. Let's look at it. But we had other issues as well, and we have still those challenges, issues today. So building a community, we have no idea how to build a community. There is basically 6 users, possible users. What's one of us in the community? So it's not a huge community to start with. Even if you talk about TSOs, they are quite limited. But we believe in that doing it in open, it helps. It's also quite hard in the TSO and RCC community. There is not a lot of experience. Of course, we see RT, who is embraced fully open source, and it seems that for them it's somehow they have managed it. But in our experience, even in Baltics, even with quite small companies, there's a lot of questions. What about security? What about support? What we need to do? What we don't need to do? So it's a lot of questions from different departments. And it's always a headache to do something open source because you will run into so many questions. And then this main question, if we pay for it, how are we going to get money back from the others? Well, I will talk about this later, but this question always comes up, that people feel that if they committed money, they somehow should get the cost that they put into it back. I will shortly mention here, we all need to make this investment anyways. So if one makes it for the whole Europe, it's better than everybody makes it 42 times, let's say, or 6 times in this case. Anyways, so this was our challenges. And then as we were a new company, we sort of have stated, at least internally, our strategy to go like open sources IT strategy. One of the main things is like philosophical, public money, public code, meaning that we are not competing entities. We are using the public money to do public services. And if we build some code, regardless if we can identify the use case right away or not, whatever we build makes like philosophical sense to make it available for everybody. If they can use it, good. If they can't use it, we can share knowledge and easily cooperate with others. It's not somehow behind walls. The same thing, easy to cooperate. Today, we share mostly English language text, or we get together in the meetings, but a lot of detail is missing, and if you want to really see if others have they done it, it's not easy way to share code. There is no, even on NSOE level, there is like commonly procured systems, but to get access to that code can be a long process, like years. The code is sort of there, the legal framework is sort of there, but the process to have access to it is so long that is really hindering the cooperation, in my view at least. Then it's standardization. If you already solve something, it's so easy to share if it's openly there. Then we also, at least from our side, see that we have quite a lot of risk of vendor lock-in. We have few known vendors in the energy sector, at least on the, and every solution is from them. It's really hard to get support from other entities. So our approach is that if it's openly there, we have a larger pool of vendors to ask support from, because we can just share. You see, our source code base is here. Do you want to provide support for us? And they can go over and decide if they want to do it or not. They don't need to go lengthy process of signing some documents to get access to that. At least we see that as a barrier to include more vendors. What we also try to do is not to build new things. We don't want to build databases. We don't want to build whatever exists already. So always when we try to do, we try to build something, we will look what is on the market. So in our case, in many business processes, you don't need something complicated. Many of business process needs are already solved. You need to store something, you need to store objects, you have object storage. S3-like things, we use Minio. You need to store some metadata or logs, you can use Elasticstack. You need to have some message bus, you can use rabbitMQ. So, I mean, a lot of business processes can be narrowed down to very simple things. So we tried to solve things with existing things and then maybe use some small integrations between the APIs to implement our real business needs. So, I briefly already mentioned them. So, as I mentioned before, it could look like we are not happy with vendors. We're very happy with vendors. We had actually very good cooperation, but it was limiting that we sort of had one vendor solution, and when we had a need to get more resource from them, it was not possible. The number of SIM experts, the number of people working on that part was limited, and no reasonable way to include more people when we had a fast change of need. So doing things open source, we see that we open up the possibility we can bring many vendors on when we have high development period, and we can use just support when we have low development periods, so it gives us the flexibility. And many times new network codes come out, we need to have more resources to test out the needs for new network codes. Other times life is stable, we don't need so many resources to be included, and to assume that the vendor has always these resources available is unreasonable in our case. We also see that what we have, we don't have a specific IT department, we have just business engineers, and we push them to write code. So all the analysts and all the engineers need to write code. It's their responsibility to implement the process. And by doing that, giving them limited set of let's say, base infrastructure, Kubernetes, Rabbit, others that I mentioned, we say that based on this, you need to figure out how to do your business process. And until now, we are doing fine with that. People, I would say electrical engineers are quite brilliant. They have no issue. They're like, okay, clear, go. No questions, no protest. So our experts have gone very good at SIM and other IT-related topics. So yeah, I would say the approach until now has worked off. And as I said before, we mainly do business-specific processing and integrations. We are not doing the whole large components on its own. To go more about the components that we have, so here is sort of the technological stack that we are using. So for running the stuff that we have built, we use Kubernetes and a little bit abusing Jenkins as a glorified scheduler. And all the powerful-related stuff, we're using pyPowSybl. Very grateful for it. It's very fast. I mean, the speed up from the previous vendor is around 10 times compared to the previous setup. For all the, we are quite architecture-wise. We try to make modular small services. We don't always deploy them as microservices because that can be hell of log handling. But we build them in a sense that we have clear APIs on messages. So the message formats often like in CGMS, but also the market sim come with schemas and things. So we try to move that way that we have clear input message formats, clear output message formats. In between you have then the business process or the processing side so that they can be linked or deployed as a one large service or multiple microservices, but the integration points are defined by the message standards or schemas. For databases, we use Minio and Elasticsearch, no SQL. We are not very fond of SQL, but that might be related to my own personal preferences. In case we talk about network models, you really don't have relational data that you want to so much keep. The files are large. We are talking about gigabytes of data for one timestamp. And it does not make sense to version or keep it. So what you do, you have binaries that are really binary blobs that contain a lot of detailed data. You just dump them to object storage, and then you extract all the relevant metadata to some sort of search engine, which we use Elasticsearch. and we also some statistics so that we can have graphs, user interfaces, things on Elasticsearch and Kibana. So here is the data flows, how it was implemented before. So this is the old structure, what we did. And mainly you see that what we are responsible for is data flows. So now this goes more deep, who is into end-to-end setup of the grid model data exchange. But there are two components, OPDM and DDX, which deal with model and data exchange. So what we need to do is to collect from the external services, the IGMs, do the validation, do the merge and scaling, so on, and then send out reports to different interfaces. This was not very efficient. This was not very efficient because in this process, at the timestamp, we start to collect the models, we start to validate the models, and then we need to publish it. We were telling to our vendor that we have 5 minutes to do this all. You have 42 models, one timestamp can be gigabytes of data, you need to validate it all, and you need to merge it all, and you need to ship it. It took hours or depending, I guess other RCCs know it, it's not a fast process. We said like, guys, we need to change the architecture. We need to do the model validation right away, restore somehow the metadata for the model is good or not, and then do the merge on the specific time. This way TSOs get feedback right away if their model is good or not, and we can do the merge fast because we don't need to do the merging at the same time. And the vendor was like, okay, this is gonna take years. And we were like, it can't be so hard. We have to be able to make it faster or maybe make it in a different way. So that was one of our motivations to try things on our own. What we started with was to sort of think about what are the different modules that we need to understand where we need to create the boundaries, as I said, to standardize the messages, to standardize the APIs, the boundaries. And basically, we got this list that we need to generate tasks, we need to retrieve models, we need to validate models, we need to scale, we need to replace. And for non-standard applications, that's often a question for many RCCs, is that it's fine, we have pan-EU decided processes, but then some TSO or group of TSOs come like, actually, we would like to do things differently in this specific case. So almost all RCCs face these local modifications. And these local modifications is also something that's hard to standardize and hard to convince the vendor to implement if one should implement the same standard process for all RCCs or all things. Then model import, export, logging and reporting, visuals and monitoring. So we sort of made these components for us that help us to understand where to draw the lines and borders, to not make one huge monolith that you can't handle, but to have sort of understandable, clear, concise goals for different components. This is maybe, it's not so bad, but I'm very close. Maybe who is not close, it's hard to see. This is the same process, but now with our more component-based solution. So what happens, the IGM validation part is completely separate on its own. It starts with getting the notification that IGM is available, the metadata is stored, the model is stored itself, and then the validation is done, then the metadata is updated about the model, about the status of the model, about the quality of the model, about some metrics of the model. That's it. And then completely separately, we have a scheduling process. We have a queue where either by time trigger or by user, a specific task message is generated with, which is what kind of models, for what timestamp, are to be merged. And then the system just asks from our internal storage what are the most suitable and best models for it. And the same process that we had with the previous vendor is then running. And the change is that we went from C#-based vendor locked version to place where we are doing everything in Python using the standard components, open source components, and have the full flexibility to test and try things. The implementation is not final, so here is some, maybe not best representation, but this is the number of TSOs included in some of the merges. And how far we are. The task generation is working, model retrieval is working, validation is working, logging is working. In case of logging, we built something that I would say that we should have been more experienced. Now we know that there is something called like OpenTelemetry, but we sort of implemented OpenTelemetry on our own. Now we have to see if we want to go to OpenTelemetry, but all the same principles we figured out on our own and did our own implementation in Python and Elastic, let's say. Especially if you run to microservices, you want to be able to group together by the business process, the specific business process run, and the specific task done, and then any step in there. Local modifications done, model import, export is done. Now where we are at is the deployment side. We have put few services already into Docker. The plan is to put all the services into Docker, but to test and run things, as I said, we have also Jenkins. So we use the Jenkins as a glorified scheduler. So so we have a mixture at the moment. Some of the services are run as a bare Python code, as a run or a task within Jenkins, and some are already deployed and automatically scaled on Kubernetes cluster. There also at the moment we have manual sharding, but we are planning to do it this way that Kubernetes has a plugin that can monitor queue sizes on rabbitMQ. So we plan to move this way that the whole setup and the number of services monitor the number of tasks in the Rabbit queues, and which will scale down and up accordingly. As said before, we see the speed improvement of 10 times from the original solution, and we see that there is possibility to improve further. At the moment, we need to do both pre-processing and post-processing, mainly to the TSO data quality, but also mentioned before, the SIM is not fully mature, so there are things that we need to fix because just different tools, different people interpret data a little bit differently, so it's easier for us to quickly align it by doing some post and pre-processing. Process is live for the Baltics, so we are not live for the pan-EU, but for the Baltics needs, at the moment it's Estonia, Latvia, Lithuania, and Poland. For those models, we are already doing security analysis. We are soon starting the capacity calculation as well. We are current sprint, we are working on the replacement logic, and the scaling is waiting, let's say, on the data quality a bit, but it's the principle is there, the proof of concept is done, but we haven't put focus there because in overall in the European process we still face a lot of data quality issues, both on the schedules but also the IGMs. So we have taken the approach to take things that provide value to the TSOs right away. So what we see is that our region TSO IGM quality we have direct control over. We can request them to make certain changes, and we can focus on the services that we provide locally, but we do all the solutions that they are scalable globally, or at least pan-EU. Yeah, so, and Baltics are synchronizing this year with the rest of Europe, as you know, or don't know. So we have some services waiting for that switch over to go live, mainly capacity calculation, but I think we are ready. At the meantime, we are working also on the pan-EU process go live. Okay, so that's what I have prepared. Now, guys, it's up to you to ask questions and have a discussion.
First, it's really impressive that you, I mean, I envy you because, yeah, I'm very impressed that by the fact that you could develop that in-house. Not because of the capacity, I'm sure you have, but how did you convince first the management, and second the TSOs? And so the trigger, I understand, was it takes too much time, right? Was that because maybe you? How was the genesis? Because some people in Chorizo are trying also to develop more open source and also in-house developments, but it's a mess because you have like TSOs and management. So sorry if there is a lot of management here, but yeah, there is inertia everywhere. And everywhere when you say open source or we will do it ourselves, everybody is freaking out. So.
It's a good question. So who didn't hear the question was how did you get started with the open source, as it's quite hard to get past management who has too many questions about it, more or less. So for us, the management is there. Veiko is sitting there. And we have very flat structures, especially in Estonia. We usually have really, really flat structures, and the responsibility is very clear. You're given some task, and it's completely up to you how you solve it. This is like the mindset. So often it's up to you. Do you procure something or you write yourself? It's usually you yourself need to procure it or develop it, and then you will also run it. So it's very like so it's very, very dog-fooding. So we usually have it, but of course we had discussions with the management. TSOs did not react at all. They are very occupied with synchronization, and RCC activities is like, it is there. Maybe it will do something, but now we have the synchronization and we are trying to boot up synchronous condensers, and we don't too much care what you guys are doing. Yeah, you have to find so you have to find a distraction or sort of there is I'm not saying in all life aspects that's a good approach, but sometimes it's better to do and ask forgiveness than to ask permission. So in this case, and this is when I'm talking about hat on the Baltic-RCC, but if I'm talking about hat on as a Elering worker, which I or employee, then there I haven't asked anybody. I have just made things and nobody cares. That's or at least they care when somebody writes that a good job. Then they are like, the management comes like, you did it, it's very good, and they have no questions about legal setups or anything. So in our case, it's the smallness and the clear responsibility that you do it, and you know that you're responsible. If anything happens with it, you need to answer it, and you need. So we have had some consultations and not raising it up too high, but to have some discussions with the legal and to make sure that it's sound enough, but not to go on the board level before I don't know, publish an API to talk with some ENSOI application that I need to have a board approval. That's not a common way for us, and that I think helps us. But I have same thing on Elering side. I have some internal code projects that I would want to make public, and there is no clear way how to do it. If it's my own work, it's easy, but if it's a larger work of piece of work, then it's hard. So sorry, I answered too long, but maybe there are other questions. Yes.
Related to this question, do you have an idea how much resources was needed and still needed for the development in terms of people or others?
So proof of concept was me alone, and I would say a week. Now the more robust version or more nicely done version, it's not fully ready, but you can see the code status there. Not everything we are proud of, but some things are quick fixes and some things are long term. So we plan to do refactoring for sure for many pieces, but we wanted to get something working. There, I think we started in January, February, and I think that the team, roughly, I don't know, Veiko can also improve, it's 3 or 4 people.
I'd say total 6, but actually
Yeah, so writing code is now 4 people, but was 3 people. But it's not like full on. So it's hard to estimate the actual workload, but I would say that it's quite minimal resources because everybody else has their own things. So I'm only half-time in RCC, so half-time I'm in Elering, and I have so my half-time, let's say, and there are other issues as well. Then there are the guy who is doing the capacity calculation, the QA guy is doing reserve sizing, so everybody put in a small portion of their time. So we do it that way, and then Veikko and some management guys for the project planning side of things. So it hasn't been like full time. It's more like a side project, like I don't know. So I think Kristjan.
I don't know too much about the RCC and how all of this works, but I understood there's 1 out of 6, right?
Yes.
And each of them has to merge in the end the script model.
Yes.
What are the other 5 doing? Like, are they going to use this, or is now again we're back at each of them is developing their own solution? Do you know a bit more about that?
I don't know how directly I want to answer that, but there are different options. Don't have
We have the answer for Horizon and TSNet. We know the answer. It's the same engine, and that's
Yeah.
why it works in 1 week. It's because it was open source already to be released.
Yes. So I said CoreNet, which is Corezo and TCNet, to RCCs in Central Europe and around it. They are going to use the same engine, Java one. The Java one is the native one. We are using the Python API. So they are reusing it in Southern Europe. They have their own solution, but I understand they have switched or are switching also to the same engine. Nordics have tried multiple options. I don't know what they're using at the moment, but they have delayed decision to 2026, I think, for implementation, 2025 for deciding. So it might be that they go a similar approach, not guaranteed. And another RCC in Southern Europe has their own solution. I don't think they are going to change that one because people have already made the investment. And we have had long working groups like what is a good approach or not good approach. The thing is that as the standard is not fully mature and there's so many modeling, there is a point to have different solutions so that we can compare. So who knows the joke with the PSSC? PSSC has a bug for a long, long time. If there is a line between different voltage levels, it uses a ideal transformer, which is not fully correct. And many engines need to implement this feature because everybody is checking against PSSC if the load flow is correct. So a similar way to avoid that we would sort of we have standardization. So SIM should be a standard, but if we have one reference implementation only, then it's not a standard, it's only that reference implementation. So I see a benefit of having different tools, meaning that the modeling standard actually becomes a standard, not one reference implementation that everybody is checking against. I saw here question, or your question was answered, but then I have in the back. Yes?
Open source seems to be a problem for some TSOs, but they have private networks. Isn't code sharing between all these software development departments within the TSO TSOs an option?
Yeah, I mean that's what ENSO has tried to do, but I haven't seen it to work. So the communication standards that have been, or communication reference implementation, so the communication standard that we are using, called MADES, is a standard, but it has only one implementation and only one vendor at the moment. And the code is, let's say, internal for the community. Anybody could ask it, but it has been asked only by few TSOs to conduct security assessments. So by external vendor to assess the security of it. No knowledge, no TSO has actually developed further or committed any code to that. And we have few other things like the same. In many cases, these things are built on top of proprietary libraries. So we have only part of the code available and the vendor is injecting a lot of proprietary libraries. Then TSOs, it's hard for them to enter to that. So in theory, it would sound good. We want to have more secure environment. We maybe don't want to put or we don't feel secure, even if it's not the question if it is secure or not, but let's say we don't feel secure to put the code out. But somehow, as we don't have the practice to share code within even internal community, it works even less. Because if you put it open source, at least you have good practices and guidelines how to do it. If you try to do it internally, there is no knowledge how to do it well, and then there is no knowledge how to use it well. And it seems not to work. I'm not saying that it won't work, but I haven't seen it working, and I don't see a tendency to it to start to work.
Just asking because there is yet another implementation since 2018 in Germany, also merges CGMS.
Yes. And I mean, the merging is a little bit... I would say that most of this is about data manipulation flow. The core concept of merge is just loading all the models together. It's nothing new or like mind-blowingly hard, but there is a lot of integrations with the other tools around it and reporting and stuff like that. And of course, then a lot of debugging of all the models, because it's like a zoo. Everybody figures out some its own way how to model something, and you cannot see all the possible ways that people can abuse the standard. Yes.
Yes, so Eduardo from Italy, two questions. One, so congratulations, I joined my colleagues from Korea, so really impressive what you developed. But I'm sure that along the way you have found many issues with the CGMES, and my question is, did your development team save an issue list of the CGMES that you would be willing to share to make it better? And the second question is, are there conversations to, as you were mentioning, extend this work for the capacity calculation or the coordinated security analysis?
Yes, so the merging part is completely open source. The security analysis and capacity calculation is also built on top of pyPowSybl, but it's not yet made open source. Veikko wants to add.
Actually, the network code exchange part for the new standard is also common. But it's not the full CSA process, because CSA process is still in tweak, even though it's live. But once we get it into a place where it's stable, it will be also available.
And we have, for the security analysis and capacity calculation, we have modified the standards. So we have added, it's not fully standard implementation, because as we are one of the first to implement based on the standards, we found some issues, and we wanted, again, first provide value for our shareholders or our TSOs. So we first implemented by knowing that maybe we need to then update it. But at the same time, many of you here in this room probably know Chavdar, so he has been updated on the changes or consulted on the changes that we have done, and on the issues that we have discovered, we have reported to NSOE already, the guys who managed the ruleset library. The NSOE developed or maintained library where we do the standard validation. So before we get the models, there is a filter that's developed by NSOE that tries to filter out the craziest things. Then we have only the things that nobody has foreseen, that we need to still investigate and understand why and how things work as they do. Other questions? In the back there.
Congratulations for your achievement.
Yeah.
Thank you.
So I think there's a lesson here. Eduardo is here as well, and I complain to Eduardo a lot because it's from NSOE. And I've been working at CGI as well. And this is, apart from sending congratulations to you and to your management for allowing you to work and to do proper work, can we not manage this process in an open source way with issues instead of paperwork?
We can, all the issues are all public. You can go to the...
Can we not learn from you as a community? And probably the question is for the people in this room.
I'm 100% with you. I think there was a previous discussion in the today's morning, and the answer was that it's not the standard way in community, and to change the de facto state is hard. I would hope, and especially in many cases from the engineers upwards, I would hope this is what everybody sees, that how it should be. But somehow management doesn't want to deal with unknown risk. And anything unknown is unknown risk. So they don't know what this open source can entail. They have their mandated tasks from the regulators. They don't want to introduce any unknown risk, and they don't see the daily job, how it would benefit. So somebody, either somebody from the management really needs to have a vision for that. I think that was the case with RTE, that somebody from the management side led it. Maybe I'm wrong. but then on other TSOs, either you have to have a very capable down-up who can convince or push it through, or then you have to have some change in the management, maybe somebody from IT in the board that is really convinced, but it's hard. And I don't have an answer for you how to get there, but I would hope that if everybody in this room and this community grows, I think that will take us towards it. And I have to thank really RTE, because I think they are really setting the scene for it. We don't have this amount of resources, as you saw. We are doing this with few number of people, so we can contribute it and happily use what is built, but we are maybe not able to make so large scale project, because this may seem like a large scale project, but it's more like gluing together already existing pieces and making it very easy for use for engineers who actually use it every day. But we are not taking up ourselves to build a load flow engine. So that's a large one. We are not taking up to build a database. We are taking existing pieces and putting together. And it may be a large project for some if you need to have the overhead of project management, analyst, business analyst, IT analyst. But if you can do this on the level that people who use it, who actually know the business process, are able to bind it together, you can do it with a very small number of resources. But this is not possible to build a database, or I would argue a load flow engine with this number of resources. Any other questions? Yes.
Very technical. Did you develop a NC for a network profile importer?
Yes, it's public there.
Yes.
Okay. So, okay, but where
Is the company GitHub is separate repo for NC profile?
Yeah, we have two implementations actually. So we have one built on in Python using the Python data structures library. I can't remember the name right away. And then we have the triple store implementation that we have done in-house, which takes the XML structure and doesn't do a triple store per se, but makes a 4-column pandas data frame, which we can use. And we have a way to define the import-export from that structure, so we can easily import and export any SIM or any RDF XML back and forth.
Yeah, it's good to know, because we have been developing the same kind of stuff for OpenROW.
The NC profile exchange, the person who developed is also a confirmative list for the vendors, so we are as a vendor there.
Yeah, so the guy who did it is actually interested also to see what you did on the OpenROW side, and anyways we are in the future we plan to invite you on a meeting to discuss this. Let's say maybe we'll use your implementation instead, but anyways this is sort of the plan. Thank you. We are 1 minute over the time, so thank you for all your questions. It was nice to